So in this video, we will discuss about the classifications of structures. So as you have seen, near to your place, so many structures you will see. It may be a building, or it may be a bridge, or it may be shopping mall, flyover, anything. All are actually comes under a structure. So now in this class, we will discuss what are the different types of structures are there, and what are the different classification, different properties of each structure. So first one is tension structure. So what is tension structure? Tension structure is basically the structure which will primarily will take only tension force. So in the strength of material class already you know what is tension, what is compression. So tension is nothing but when you apply a pulling force. For example, this is a member. So one force is acting in this direction, another force is acting in this direction. So this member we call it a tension member because force is acting here and this member is undergone into tension. So if a structure is only stable when the tension force is acting, or in other words, if a structure will have subjected to only tension, that structure we call it tension member. Now, what is compression member? Compression member is just opposite to tension member. So for example, this is a structure, and if a load is acting in a compression manner, so like that, so this is actually a compression. So this is your compression structure. So if a structure is subjected to only compression force, that we call it as a compression structure. Similarly, if a structure is subjected to tension, then we call it as a tension force. Now, truss already have gone through. We have done different analysis of truss. So truss is nothing but when, for example, sorry. So you saw different types of truss will be there. So when the tension and compression members are connected through the pin joint, that this is called truss. So truss is also a different structure. So now can you tell me where did you get the tension member? Tension member where can you see? So in many places you will find tension member. For example, suspension bridge. You might have seen different types of bridges. One is cable stayed or the suspension bridge. So suspension bridge will sometimes look like that. So some cable will be connected and this cable is connected to ground ground and this is your river and this is the suspension bridge. So through cable this bridge is actually tied. So these are the cables which are actually taking that load of this bridge. So these cables and this is also a cable. So this cable is only subjected to compression tension. So this is a tension member. Similarly, for your structure where concrete column is there, right? We have columns in a building. So column will have subjected to compression because only compression force is coming in a column. So this is a column is the example of compression member, whereas this cable is a example of tension member. Now, similarly, what is truss? Truss already you know these are the members when it is connected through pin joint that we call it truss. Now, next is shear structure. What is shear structure? Shear structure we'll discuss more in details, and then bending structure. So whatever beam we saw in a building is consist of what? Slab, beam, and column primarily, and then foundation. These four major elements are there in a building. So bending element means which member will bend after the load is applied. For example, this is a beam and load is applied here. So after the application of load, your beam will bend in this fashion. Maybe I just drawn it too exaggerated manner, but in real case there will be bending. So this is a bending structure. So these are the different major classifications of structure is this. Okay. So now we'll discuss one by one in each case. The first one is tension members. As I have already explained. So this is a cable stayed bridge, and this is a bridge deck where the passengers load is going, and these are subjected. These are cables are basically carrying the load. Entire bridge is resting on these cables, and this cable is connected to this main cable, and this from this main cable load is connected to through this spire. It will go to foundation. So this is the entire load path. So basically, this cable is a tension member because cable can only take a tension force, it cannot take compression force. So if we apply a cable and if you apply compression force in a cable, so what will happen? It will simply its shape will be like that. So it cannot take any compression force. So these are the few examples. For example, this is two beam connected. Now, if we apply a load, so this P load. If we apply in this direction, then this member and this member, both the member will be subjected to tension force. Similarly, here this is a bridge. So same bridge, these piers are basically these cables are basically subjected to tension member. So this BC bridge is actually very famous bridge. That this bridge actually collapsed because of some wind load. You can search in Google Tacoma narrow bridge. If you type and search, you will get the exact failure of this bridge. This is also a suspension bridge or the cable stayed bridge. Now this figure is actually a stadium in China. So this stadium is basically indoor stadium, but here you can see at the top. So this is nothing but a roof. They made it roof in such a manner that from bottom actually they are blowing the air. Because of this air, so air is blown from bottom. So because of this air, this roof shape is in this inflated manner. But if the so this force in this roof will be basically a tension force. So these are few examples of tension member. So now we'll see the compression member. So as I have already discussed, compression member is only where the load is acting, only compression load. So this is a member, compression member. So in your structure, all the columns are basically a compression member. So this is a structure. So here this column. So this is one column, this is another column, this is another column. So these all columns are basically subjected to compression. So we will call it this element as a compression structure. So column is a compression structure. Now similarly this is arch also. If you see this is arch, and if we apply a UDL, uniformly distributed load, so this arch will try to bend. So ultimately compression force will be generated in the arch. So this is also an example of compression member. So this arch is actually stable through compression. So next is truss and the shear structure. So truss already you know, when the two member is connected through pin joint. So this is a pin joint. So please remember that in truss always the connections are pin joint. So these buds either can take compression or can take tension. So that's what the tension the truss member always can take either tension force, or either it can be tension or it can be compression. So only these two type of force truss member can take. So in truss you can see in many places, like railway platform. If you visit at the top side, you will see the truss is actually carrying the entire load of the slab. So similarly, you can see in a shopping mall also, where the roof is basically a truss board. Even in airport also, if you visit Hyderabad airport, you will see from the top there is huge truss is there. So truss is very helpful when the span length is very high. So see, the span length is very high. That means in that case you should use truss. Actually, truss very less. I mean, you can have more spacing between the two columns. So in that way, you can maybe a warehouse or factory, all these places you can go with truss for the roof panel. Now similarly, for the shear structure, so what is shear structure? Shear structure is nothing but this type of structure you will see in some modern buildings. The entire element will be a filled as a concrete. So this is structure, we call it shear structure, when the entire wall is made up of concrete, some reinforced concrete. So some advantages are there if you use shear structure. So shear structure has more load carrying capacity. It can take vertical load as well as horizontal load also. So nowadays in many places we prefer shear structure also. So that's the we discussed three four types of structures. Now the next type of structure is bending structure. What is bending structure? Already I have discussed the structure where uh, it will bend after application of load. Little bit bending will. So because of bending, the structure is stable. So if we apply a load, vertical load here, consider this is a beam and two support is there. And if we apply a vertical load here, so this beam will little bit bend. So because of this bending, this beam will take load because of bending. So this type of structures we call it bending structure. So you can see here two-story frame, portal frame. So here also UDL is acting, and this beam will little bit bend, and the entire load will be distributed to this column. So that is the bending structure. So whenever you see any beam means always load is acting vertically, and this will be reflection also will be there after application of load. So similarly, you can see this picture nowadays. These constructions, all these crans are actually constructing this building. So buildings basically in beams are bending member, columns are actually compression member. So now what is analytical model? So now you understood what are the different types of structures. One is tension structure, one is compression structure, another is truss and shear structure, and then you saw the bending structure. So these are whatever I have discussed till now, it is a theoretical structure. So now in reality, you will see structures will be in different shapes. So for example, this is a real bridge. So, but when you analyze a real structure, you have to convert this real structure into a analytical model where you can do the structural analysis. So this is a complex, and real structures are very much complex. So if you apply the real our methods, structural analytical methods in the real structure, then you will find lot of problems. Why? Because structural shapes and all everything are actually very peculiar. So see this joint. So we'll consider this frame as a truss, but truss all the joints are hinge or pin joint. But in reality, all the joints may not be perfectly pinned. So in that case, we have to make some assumption. So real structure will make some assumption and will draw a simplified structure. And then we'll apply our structural method here and we'll get our deflection and everything. So this is a real structure, what I am talking here. So this is a real structure, and each joints are basically not exactly pinned. See, there is a plate is connected in that plate, so many bolts are there. But what we idealize for analysis, we'll convert it into a pin joint. We'll consider it as a pin joint. So see, this is original joint. If you see one base plate is there, in that plate, these are the bars are connected here. If you consider this is a plate and these bars are connected. But what we idealize it as all bars are connected in a single point, and this point is connected through pin. And this is our ideal structure, idealized structure. So original structure is this one, but we idealize to this one, idealized structure, and then we apply our structural analysis methods to find out the deflections, bending moment, shear force, all these calculations will be done with this structure. Okay, so that is so how accurate we predict our the complex structure into analytical structure, that accurate we will get the result. So this conversion is very much important, how we can uh, represent the original structure into a analytical structure, and then we'll apply our structural analysis methods. Yeah, so in this lecture today, what we have understood is different types of structure, that is classifications of structure, and at the end we saw the analytical